Hey guys, so I thought I'd go ahead and I'd show you the latest project that I've been working on. So basically I have some of these LED matrices here. They are 5x7 and I put 3 of them together along with 4 8-bit shift registers. And basically one shift register controls the cathodes, and all the cathodes for these matrices are connected. So the first cathode on this matrix is connected to the first on this, and then this is connected to the first on here. So they all share common cathodes, and then the other 3 shift registers go for each of the displays. So one of the shift registers will go for the first one, the next one will go for this one, and the next will go for this. All of this is being run off of 3 pins off of my Arduino here, and that's just for the data, clock, and latch pins for the shift registers. And these are 74HC595s, so you can easily daisy chain them and just make them work really flawlessly. So I'm going to go ahead and show you what I have running on here. Turn the light off, flip the power, and then restart. So it's in its restarting. There's my name. And then this is just a little part of the code that I wrote to show that I can control each LED individually. And then it goes through and swipes through a couple of times. So my hopes for this is to eventually, I have, let's see, I have 2 more of the displays here. And my goal is to add 2 more of these. I ran out of breadboard room, so I couldn't do it anymore, but my goal is to add 2 more of these and then perhaps put them onto some press board, such as this big size. I'm hoping that I could probably, let's see, fit all of this on here. That would be my hope. And yeah, if you guys want to know where I got all these, I got pretty much all the parts off on here except for the Arduino off of Jameco. So I mean, everything here, along with the resistors, the shift registers, and the matrices, I got from Jameco for probably, these were 99 cents each, and then these were like 25 cents each. So gosh, only a couple bucks, less than $10 for all this. And then I have the program up here. So I'm not doing anything fancy. I'm basically right now I'm just using the shift out command, and I'm shifting out for all of the displays at the same time, and then I'm latching. So then I go ahead and I pre-programmed all of these different animations and whatnot. And it's not very efficient, but it works for what I'm doing now. This is kind of just like a test run. So I have that, and then in my loop here I went ahead and basically I looped through each of the animations a couple of times. So this first one, because the I have this I integer here, and this basically is the delay in between each step in the animation. So because that's set to 0 here, I have to go through this animation 500 times in order for it to be visible for half a second. So I do that for a couple of the animations here, and then some of them go slower, such as this snake animation here. I only wanted it to go through once, so I set the delay in between each different step in the animation to 75. I believe that's milliseconds. So I'll go to that snake pattern. So the snake pattern starts here, all snake, and basically each shift goes for a single part in the animation. So in between switching out through each of these shifts, it delays once. And we can see that in the definition for my shift function. Basically it latches low, then it shifts out all 4 of the data that I need, and then it latches high, and then there's a delay with the I integer. And the I integer is defined when I call the function here. So it's fairly simple. If you guys want to know my exact circuit on how I built this, I just did it off of out of my head, and then some reference sheets that I had found online. So if you guys want to know about any of this stuff or any of my code, just leave a comment and I'll let you know.